First, the record. 21 people were killed and about 150 injured when the wave reached the streets of the North End. We begin here quietly because every drawing in this catalog begins with what it cost. On a January noon in 1919, a steel tank on Boston's waterfront tore itself open. It had leaked since the day it was built. The company painted it brown to hide the leaks. Nobody asked the one question that mattered. Why? Now, the design as it was meant to work. A steel cylinder 50 feet tall and 90 feet across, riveted from curved plates, built to hold 2.3 million gallons of molasses, about 13,000 tons. On paper, a simple thing. Hold that thought. If you'd rather understand why things break than watch them break, subscribe. A new failure is drawn here every week, and each one is a reason you are safer than you know. Here is the first flaw, exactly where history left it. The man who oversaw the building could not read the plans, and no engineer was ever asked to check them. The tank was never even filled with water to test it before the molasses went in. And the steel itself was wrong. The walls were about half as thick as they should have been, even by the standards of the day, so the metal sat near its limit when the tank was full. The safety margin engineers called for was roughly 4. This tank had far less. There was a second weakness in the metal. The steel was low in manganese, which made it brittle in the cold, the kind of metal that does not bend and warn you. It simply cracks. And the cracks like to begin at a rivet hole. Now the load. Molasses is heavy, and a tall column of it presses hardest at the bottom. That outward pressure tries to stretch the steel ring around its circumference. Engineers call it hoop stress. The lower the wall, the greater the pull. Watch where the amber gathers. The greatest pressure, the thinnest, brittle steel, and a row of rivet holes by a manhole all meet at the same low corner of the wall. The day before, a warm fill had been added on top of cold, brittle metal. The steel could not stretch. At a rivet hole on the lower wall, the brittle metal reached its limit and a crack began, and brittle steel does not crack slowly. It ran along the line of rivets all at once. With the wall unzipped, the pressure had nowhere to go but out. The shell peeled open and the tank emptied in seconds, a wave about 25 feet high, moving near 35 miles an hour. Not because molasses is strange, because the steel was too thin, too brittle, and never checked. After 3 years of hearings, the court's auditor found the company responsible. The cause chain was plain: a tank too thin, too brittle, never tested, cracking at the rivets it was hung on. The metal had been near its limit from the first fill. And here is why your tanks hold. Massachusetts, and then state after state, began to require that construction plans be reviewed, sealed, and stamped by a licensed engineer. The empty signature box on this drawing is the reason the stamp on yours exists. Failure mode: tank rupture. Underdesigned, brittle, and never tested, a crack along the rivets it could not survive. Nothing breaks without a reason. Now you know this one. Drawing filed. Like and subscribe to support the channel.